Going to the cloud. All right, welcome to the workshop on Biopython. So in today's boot camp, I started the recording, by the way. I have a couple of announcements. First, I did not post the schedule and the recordings this week, but they are going to be posted on the Discord by the end of this workshop. And you can check the lesson link, the recording, everything on that link. So yeah, we have that up, and the schedule will also be on that spreadsheet, right? Any questions about that or anything from last time before we start with the lesson? Alrighty then, let's start with the lesson. So yeah, as I was saying, today's lesson is going to be on this Collab notebook. Collab basically helps you open any IPython notebook. You can also use Jupyter Notebook for this, but I think Collab basically allows you to do that without setting up Jupyter Notebooks and Anaconda. So it saves us the pain of like helping you set up in case of like technical errors or some incompatibilities. So in Collab Notebook, we have the text as well as the code on the same document, right? On the same IPython notebook, basically. And for these code cells, if they're followed by an exclamation mark, that is basically shell, a shell command. And if that's not followed by, if it's just plain, it's just Python code. So most of it's going to be Python code, but anywhere you see the exclamation mark, it's a shell command. And you don't really need to understand what that shell command, like each part of that shell command is, but you can just ask what this command is doing in general. All right, so Biopython. So why Biopython, first of all? If you've worked in a lab or if you're looking for a lab, right? All right, so, right, I need to walk you through how to open this actually. So once you have that link, oh, it's not working, huh? Give me a sec. So I'll share the link of the Google Drive. I'll try to do that. Okay, found it. All right. Sorry about that. Looks like the IPython notebook link wasn't very helpful. All right, so go to this link and it'll lead you to this folder, workshop 1 Biopython. I'll share my screen again. Right, so once you're here, right, right click on this and say open with Google Collaboratory, right? And you probably don't have edit access to this, hopefully not, because this is the original notebook that you won't edit. You want to make a copy of that in your drive, and that'll open the version that you can edit. This is what you'll work on. Let me know if that doesn't work. Hopefully shouldn't be a problem. Let me know if it works for anyone. Right, so some people just joined. So the last, you should probably have Google Collaboratory, and if you don't, okay, so if you don't have Google Collaboratory, just go to like collab.research.google.com. That link should work for you, and let me know what does it show you after that. Although it probably should, I think. Does it not work if you don't like do you not have Google Collaboratory by default? Okay, so works for me. Oh, okay. Just search for a Google Collab maybe. When you go here, probably should show you like add collab or get collab or something like that and try to get it. So Carter, does it work for you? Please let me know. I really don't want to waste time. So like if you won't tell me on time, we would keep delaying starting to listen.
Yeah, it works for me. I don't know.
Have you used Collab before, Carolina?
Mm-hmm.
Okay, so it I guess you can get it installed now. Cool then. Try to get the collab as soon as possible, and I'm gonna repeat the instructions for that just once more. Okay, so once you're here, if you have Collab installed, you should be able to open it with Google Collaboratory. And once you reach here, you need to save a copy in the drive, right? Save a copy in drive. I already have a copy right here. So it creates copy of biopython.biopython notebook, and this is the version that you can edit, right? If it still doesn't work for you, please raise your hand. I will send you to a breakout room and Carolina can help you. Okay, I don't see any hands raised. Does it work for everyone now? All right, Kira, do you have it?
Yep.
I'm good.
Awesome. Awesome then. Yeah, so let's work on our copies. So this was setting up Collab and Collab notebook. Right, so Biopython. Let's talk about Biopython again. So when I'm in a research lab, right, there are some basic tasks that I have to do. Suppose I have the DNA sequences, for example, in a FASTA file, which we'll be working with in this lesson. Okay, so someone gives me a FASTA file and I have to look at the sequences. Right now, how a FASTA file looks basically is it has those DNA sequences, but it also has like other lines in it. So how do you parse it without explicitly encoding for it, right? Like I don't want to build the code to parse a FASTA file. I don't have time for that, right? And so unnecessary. There's other things I have. I personally actually had like a sequence, like, I don't know, like many bases. Like I think it was at least some like 100,000 bases. And I had to like get the reverse complement of a particular section of it. Now for these things, yeah, you can use Python, a standard library, but like there's more efficient ways and you don't have to code ways to get the reverse complement or transcription, translation, all of that stuff, right? So for that, and also for alignments, for making alignments, you're not going to build an alignment pipeline like using like Blast, online thing, or like using AliView or some other software. You want to do all those alignments in the same script. What do you do then, right? So for those basic bioinformatics tasks, we have Biopython. So today, using Biopython, we'll first explore what Biopython is and how these Biopython objects, the basic objects, work. We'll like look into the documentation to find how to do some stuff like reverse complements or checking the presence of a substring or GC content. And then finally, we'll also explore how to parse a given FASTA file and how to use NCBI on the same script using Biopython, right? Like how do you use BLAST basically using Biopython on the same script in the same Python file. All right. First of all, you need to get Biopython because when you start with the collab, you won't have it by default. So it won't take long. All you have to do is run this. Okay, on collab notebooks or Jupyter notebooks, for running a cell, click on the cell, or if it's not selected already, and then press Shift plus Enter or Shift plus Return, and that should run the cell, right? So yeah, with that, if you click on the files thing, if you're not in the files thing, sorry. But basically this should install Biopython, and the way to check it is to run this cell, right? So Shift plus Enter, Shift plus Enter. And when we import Biopython, import bio, it says Biopython version 1.79 when we print that Biopython version. So it means we install Biopython 1.79. Now let's look at some things that we are importing here. Seek.io, Search.io, Entree, Seek, and GC, and Blast, NCBI, and data code on table. So that looks like very basic bioinformatics stuff that we would want to not do ourselves, right? Right. So first of all, the first basic object that you need to care about is the seek object. Usually, using standard library, you would represent DNA sequences or RNA sequences as a string. To use Biopython functions on that, you need to build a sequence object, a seek object. And the way to do that is very easy. Just say seek and then the string for that sequence. So suppose you were reading a file. First, get the string of that file and then put that into a seek object. And then you can use any Biopython function like transcription, translation. Yeah. Right. So yeah, let's look at the seek object first of all. So RNA is the seek object made from the sequence. And here we're going to try to run it. Oh, sorry, I need to run this first. Shift plus Enter, Shift plus Enter. Yeah. So this is what it shows, literally the seek object of this, right? It's not very helpful, right? Why are we doing that? Because as I said, we want to use functions like translate, right? So let's try that. So we have the RNA sequence here, right? What does the RNA get translated into? Like what amino acids would it get translated into, right? That's what we, when you try to, okay. So all you do is RNA.translate, right? Like that, and then run that. And it shows you the amino acids that would be translated based on the RNA sequence here. All right. So for people who didn't, for anyone who couldn't install Biopython successfully, just go to the first cell and press Shift plus Return, Shift plus Return, and Shift plus Return, Shift plus Return again, and try again so that you can just check if the Biopython install works now. Print RNA doesn't print anything. Print RNA should print something. If it's not, that'll be interesting. Okay, so people are still having, wait, so does Biopython install work for everyone, or does it still give you problems? Raise hands if you have some problems with Biopython install. Yeah, you need to shift plus enter. So shift plus enter basically means running the cell, and you need to run this cell. This. Yeah, this should be the first thing you do because you need Biopython installed before you can start using it or loading it. Yeah, just make sure that you have this appearing. If you don't have this appearing, please raise your hands. Okay, looks like just people didn't run it earlier, and maybe that's why it wasn't working because nobody has their hands raised now. Yeah, please let me know if there's any problems. It's okay.
Hello.
Yes.
So I successfully installed Biopython. So it says requirement already satisfied when I run it again. But it's just importing is like problematic because it says no module named bio.
Okay, so when you do pip install Biopython, it says requirement already satisfied.
Yeah.
And when you try to import bio, it gives you an error.
Yeah.
Okay, that's weird. So can you make sure that, can you try running this? Pip show Biopython, because that basically confirms if you actually have Biopython. Okay. And tell me the version. And also location.
1.79 and location. Downloads.
Should be exactly this.
Document slip.
Wait, are you on Jupyter Notebooks or?
Yeah, I'm on Jupyter Notebook.
Okay, so what you need to do is, for anyone who's on Jupyter Notebooks, they should try Conda install instead. And if you're on Google Colab, then you should try pip install. I think Conda install should do the trick. Let's see. Try that. I didn't realize that actually. I thought like pip install should work for all. Does it work now?
So it says this bunch of stuff, and this is proceed YN.
Okay, so what you need to do is you need to go to terminal to do it.
Ah, okay.
Yeah.
So should I be in the correct directory for this?
I mean, you can go like basically anywhere, I think. Anywhere. The location shouldn't matter.
Okay.
Yeah.
So I try to do !conda install Python in terminal, and it says conda event not found.
Conda not found. I would really recommend that for the sake of consistency and ease, just like use Google Colab for now.
Yeah. All right.
Yeah, that'll be the easiest way, I think. All right. Let me know if you have problems with that. So for the next part, actually, we are going to be splitting into breakout rooms and discuss kind of in smaller groups and working on this challenge problem, basically. All right, so let's first talk about that, and then I can take over Justin. I can help you with that. Right. So yeah, so we have the amino acids. That's where we were. We just translated this sequence using Biopython's translate function. And now you can just go to the table and confirm Another way to get the Biopython, another way to get the amino acid table is to actually use Biopython for that. And for that, you should explore the documentation on your own. How do you know, where do you find it? Well, the Biopython documentation link is here, okay? And you would go to imports and see, okay, so bio.data.codonTable. So go to that part if you want to look into it. That's an example. You'll be using the same technique, the same method for like other functions that we're going to be finding right now. All right. All right. So before that, you need to get two files. And for that, just run this and then this. Okay. So this cell and this cell. This cell is going to give you a FASTA file, right? So you see these just appeared on my left pane in files. So unidentified.fasta is here. And then the next one, biopython exercise.py is also here, right? So go to your left pane. First run these cells, then go to the left pane, files, and then check for these two files. If that doesn't work, let me know. Or just unmute, honestly. This doesn't work. Yeah, so what you were supposed to do was, so you go here, then you go open that with Collab Notebook. And then you're supposed to go to File and save a copy in Drive. And then you can work on that copy. If you have these files, then please raise your hands. As you raise your hand, I'll be splitting you into breakout rooms. Okay. You know what? I'm gonna assign everyone to breakout rooms first, and then we can, and Carolina can help you. Okay, that works. Alrighty, let's. So yeah, the unassigned people can just stay here. This will be another breakout room, I guess. All right. So Isabel, it says I don't have an application to open the genetic data. What step did you get that error? Is that in the first cell?
Yeah, it was the first cell, and like it downloaded, but then when I click on the download, says there's no application
no, you don't
to
have,
open.
Well, which download did you click on to here?
It was the get the genetic data cell, and then like the link in it.
No, you don't click on the link. So you need to click on the files and then here.
Sorry, where do I click?
So you download this by running it, and then you go to the left pane, files, and then the file name, unidentify.fasta.
Oh, okay.
Yeah. Right. So yeah, so this is the exercise basically, biopython exercise.py. You double click on the file biopython exercise.py, and it should open the exercise on the right. I would drag this a bit, right? So now what your goal is, you need to edit the file exercise.py. It has 4 functions: complement, transcribe, check substring, and get GC. You don't have to look beneath this point. So edit this function, complement, then edit transcribe, and edit check substring, and then edit get GC. And you're expected to basically check the documentation from this link, right? So here, go to the documentation and find the functions that, the BioPython functions for these tasks, for these 4 tasks. All right. All right, I'll be back in a minute because I need to go to the other room to help them out. All right, does it work for everyone, by the way? Like, is everything working for everyone?
I think everything's working for me
All
for
right,
now.
cool.
Same here.
All right, then see you in a minute. sorry about that. Thanks for letting me know. But yeah, so, oh my God, that is so, right. So what I wanted to say was you have these 4 functions, right, in this file. You have to make changes in this file, edit it here. Do you know how to open it here? Can you all hear me now?
Yes.
Right. So yeah, so discuss and all the breakout rooms people will all get together around 125 and then discuss what we did. You basically want to edit this file and then run this to check cell to check if you got them right. It'll give you feedback on which functions you got wrong. Well, it'll go in the order. So you need to get complement correct first, then transcribe, and then check substring and get GC. So yeah. Do you have any questions?
I have a question about the find method. Like in the documentation, it looks for like the second example where it's like .find TAG. And I wasn't sure if like it returned -1. I wasn't sure if that's like the index, because I don't know if it like looks at the last one and then goes back to the front. Like if it returned -1 since that's the index, or if -1 means that it wasn't in the sequence.
Great question. So yeah, -1 is actually, -1 does, well, what do you think actually? Shouldn't the documentation kind of like say something like that? Right. So yeah, you're right. TAG is not in this file, right? Oh,
No,
wait.
but
I
like
get a point. I get a point. So T and then A and G, right?
yeah, so I wasn't sure if it
Oh,
scans
no,
back or something.
-1 means not found. Yeah.
Okay.
-1 means not found. They did not come up with the best example, I guess. Good catch. But -1 means not found. Yeah.
Okay, but then any positive number tells you the index that it's at?
Yep.
Okay.
Mhm. Alrighty then. If you have further questions, Carolina's here with you. I'll see you in a minute then. We'll gather around 125. All right, welcome back, everyone. Let's wait for everyone to join. It looks like some people are taking more time in the breakout rooms somehow. All right, welcome back, everyone. So we had these 4 functions, right? Complement, transcribe, and check substring. So I think the first 2, do you think the first 2 were kind of easier than the rest of the 2? How do you approach the complement and transcribe function? Those are pretty easy. Let's just get them out of the way and discuss them quickly. Documentation does safeguard if you're right. Yep. All right, so yeah, so I don't remember actually the function for transcribe. I know that for complement, I think it was just a complement function, was it? It was just complement, right? Dot complement?
Yeah, and transcribe's the same.
Oh, wait, let me start. Oh, yeah, we're recording, right? So dot complement. Transcribe was same? Oh, I see.
Yeah, it exists on the sequence.
Nice. And then the third was check substring. Let me share the screen. Right, so third was check substring. Was there a check substring function as well for that? Like a direct way. So for the first one, you said dot complement worked. Oh, okay. And for the next one, transcribe worked. Oh, not trying. But what about this one then? Was there any like built-in function for this as well? How do you all approach it?
I use the dot find.
Oh, dot find like that?
And then with the subseq in
Subseq in it. Right. So find method, what does that return? Like, does it return just 0 or 1 or something like that? Or
it's the index that the subsequence occurs, and -1 if it's not found.
Nice. So for our method, we are either supposed to return true or false, or we can even return a positive number for true and a negative number for false. So dot find is returning either the index or -1. So index if it's found, -1 if it's not. So I think by itself it should work, right? Because the index is going to be a positive number, and if it's not there, then -1 is going to be the negative number. So it should work, right?
It should work by itself.
Right. Even in 0, I think. Even in case of 0, I think it should work, right? Yeah.
We actually checked in the main, and it's greater than or less than 0 are the only cases, but equal to 0 is not a case that it covers.
Okay, for the tester, you mean?
Yeah.
Right, because I see your point. Yeah.
You could add it though. It's probably implied that 0.
That's a good catch. So how we are checking this is, trying to check if the sequence is present. Right, so it should basically be, but I don't want to change the test, right? You're not supposed to look at the test. So how do I do it? Okay, I mean, I guess I can, I guess you could do this, that like if it's minus, you can check if it's -1 or 0 or not. Like this return.
I think it's just that the test case itself doesn't, like there is no test case for 0, so it's impossible to fail it.
Right, but like I'll have to still update this way if I were to add a new test case.
Yeah.
Yeah. All right, it's okay. I'll update that, honestly. Yeah. Right, and then for GC, how do you do it? Did anyone use like seek object dot some function?
I used dot count twice, once for G and once for C.
Okay, so
I added those.
C dot count plus G, and then the same thing for C. And then to convert into the percentage, I guess length of seek object.
Yeah, and then times 100.
Oh, right, times 100. Okay, let's try that first, I guess. So to check this, we'll go here and then run this. File opened. Oh no, something's wrong with the GC method. Oh, never mind. I didn't put any brackets. Sorry. Oh, okay, we made it. Nice. But I remember there being a more direct function for getting the GC actually.
Yeah, in this sequence util import it.
Right. So if you scrolled to the top, right, to the top of this file, you might have noticed there was a small hint that there's a GC function here, right? So if I want to check the documentation for that, then biosqls.package and then biosql you have the GC function and you have an example here. So you can actually use just this function. So I can return GC of seek object, and that should give me the right answer as well. Awesome. Thanks for discussing. Y'all are really smart. Y'all got it. Great job. All right. So now for the second part, this FASTA file, instead of looking at the head, we can just open it even honestly. Yeah. So this is the header line, what it's called, right? So Justin, come on, Justin. Yeah, I'm sure you were a nice team, like a nice teammate, and you supported Austin in some way or the other. Pretty sure you can make a good team, Austin and Justin.
Yeah, we also the same name.
Right. So for this FASTA file, right, you have this identifier, the greater than identifier. I mean, the greater than symbol that tells that this line is going to be just the identifier and not actually a sequence. So essentially, this is going to be the heading for the sequence that follows it. Wait, what? Yeah. This is going to be the heading line for the sequence that follows it. This file has only one FASTA, but it could even be like this. I just copied the whole thing again. So you have two sequences now, one with this header and one with this header. So say, for example, I change this into a this, and then I save it, right? So okay, this is just reading the first line. This is not going to be much. It's just going to read the first, I guess, 8 lines or something like that. I think it was 8 lines, but yeah. So instead of reading and checking if the line has the symbol or not, and then if there's a new line or not, what you can do is seek.io has this function called read, which can help you read different file formats, not just FASTA files. It can help you with FASTA, FASTQ, and some other files. I think you should check out the documentation for that. So we're going to use this seek.io.read to open the FASTA file. And since I have edited the file, you can also do the same, copy, paste, and then maybe add this underscore. but let's see what it does. So record is seek iota. Yeah. So, okay. What you get is an error, I guess, because it says more than one record. So in just a matter of seconds, it went through the whole file and could read if like how many records it has. So instead of making a for loop, this is much better approach, I think. Also because like you don't have to make the for loop. All right, so just with the first sequence, original file, it's gonna run and make this record object now. We have looked at the seek object. Now we have a record object. Let's look at the type, what exactly this is. So Python has this type function, which you can use to check the class, check the type of any function, any object, sorry, any object. So it's bio.seek record.seek record. That's what the object is basically, right? I'm gonna delete this. Right, now record has attributes or field variables, ID and seek. So ID is gonna be the ID here, the header, and then the sequence. So let's run that, right? So what do you notice? Does it show the full header as the ID? Right? So it says just unknown, and then it ignores the rest, right? Apparently, this ID function ignores everything after like a space, a white space, and then just records the thing before that as the ID. And the sequence is the whole sequence. It's going to be till here. Yeah, everything. It goes into a seek object, the seek object that we saw before. So on record.seek, I can directly say like translate. I can do that. Yeah. Do you know what this asterisk stands for? Here, does anyone know that? Any ideas what it might be?
Stop codon.
There we go. Yeah, so that is the stop codon actually. You can probably check here. Yeah, you are free to check the sequence and find the first stop codon. But that is very much the stop codon basically. Yeah. All right, let's look at the ID again. What if I change this to include an underscore instead and then save it? Oh wait, it didn't save, I think. Oh, sorry, I have to rerun the record, read it again. Now what's the ID? Right, now it includes the underscore stuff, but still ignores this stuff. And if I delete the white space here and then save this again, and then read the file again, and then the ID, then it gives me the whole thing. So basically it's ignoring everything after the first white space. Just be mindful of that. All right. Right. So, okay, you have the sequence. You don't know where it's from. It's unknown, unidentified sequence. Now, I think in the first lesson, if you have attended that, we discussed like, we can use BLAST to match a given sequence to an entire database of sequences. So NCBI BLAST is a database with all these different sequences from like all over the world, different samples, different organisms, everything. And Biopython allows you to do that without opening a new browser window, No. So you basically do that in the same script. You do it in your Python code. You can do it from here. All right, so we're gonna blast our sequence, that is compare it to the database, and then find out what records it matches to. And BLAST will tell us what organisms those matched records are coming from. So our sequence will have a higher probability of coming from that, whatever that organism is, those matched records. Like if this sequence matches to a 90% or like 99 or 98% similarity with, I guess, a giraffe, then this must be coming from a giraffe, for example. So let's see. Biopython's bio.blast module has NCBI WW package, and that itself has QBlast method. So you give it blast n as your first parameter, which this argument basically means which kind of blast you're doing. So blast n basically is blast n nucleotide. And then you tell it what's the input type, basically. Like, is it nucleotides or what kind of is, yeah. You can even check it here. So bio package, and then bio dot, right, NCBI WWW, and this should have the QBlast, right? So the first input is the program that we're using. Oh, the second one is the database, so nucleotide database. That's what we are looking into. Yeah, my bad then. The NT does not indicate what the input type is like. It indicates what we are matching to, what kind of records are we matching to, yeah. So we're matching it all to all the nucleotide records. And the third variable, the third argument is going to be the sequence that we're looking into. There's all these different default arguments. As you can see, all of them have the equal sign, so they have like default values. So we're not going to change any of that. You can if you want to. All righty. Let's run this then. It's going to take some time, so you should run it now. Right, so does everyone have this running right now?
Yeah, I'm blasting.
Blasting, nice. So you can see that they have different programs: blast in, blast nucleotides, blast protein, and blast X is, so I think blast X is, if your query is, wait, it's basically like one thing is nucleotide and you're matching it to amino acids. Yeah, so I think, I can't remember exactly which one it is. Let's see, NCBI blast. Okay, so it goes from translated nucleotide to protein. So RNA to protein. And then T-blast N is the opposite, protein to translated nucleotide. So your input is translated nucleotide and you're matching it with protein. And then here your input is protein and you're matching it to translated nucleotide. All right, in the meanwhile, this is still running. Yeah, you can explore some other stuff, I guess here. Which database do you want to search it against? So suppose I was gonna do this here. Suppose I go to nucleotide blast. Now my input is FASTA. The database options I have are standard database, which is NR. NR or NT are both nucleotides. Then we have PDB, we have all these different files. Yeah, all these different databases, sorry. All these different databases that we can use. WGS, SRA, I think this is used more for like population genetics. You know, or at least I use this for population genetics. All right, our results are here. Hopefully yours will be here soon too. Let's, oh, no, my God. Oh my God, no. Okay, never mind. Okay, cool. So just, can I? So yeah, it worked for me. So result handle, we can see what result handle is like. What did I do? Oh my God. Result handle. So .io, .string io. You can check the type for this. It's io.string io, right? So what you'll notice is that this is not even a Biopython thing, actually. It's a string input output. It's string, I guess, it's like a string, I don't know, buffer, but like something related to that, which makes finding the results faster because there's so much data in this string that, yeah. You could try to do this. We can try to read it maybe till maybe the first, I guess, 100 characters even. Oh, doesn't give me anything. Yeah, okay, that's a bad move, by the way. Let's just go with it. Don't do this what I did here. I was just exploring. Yeah. So search io.read allows us to look at the blast file, which is an XML file. So result handle will basically be a like a blast XML file, kind of like it'll hold information in the form of a blast XML. So just pass that to search io.read, and this is what printing blast QResult will give you. It'll show you, okay, you have your program blast in, then what's your query? Your query is, it has this number, you're like an ID kind of for your blast run. And it shows that you have some 0 to 49 hits here. And all of them happen to be coming from your Yersinia pestis, right? You can even make this cleaner. So you have the blast QResult object now. You can look at the object itself. It has 50 hits, right? So if I do like say 48, for example, it will give me this hit. So, you know, CPO 3370 and yeah, right. This is the ID for that hit. And then this is the description. This is a description. So if I want to check the description of this particular record, I'm going to say .description. Right. So it says Yersinia pestis strain, this plasmid. Yeah. don't know why. I know I read it, huh? Oh man, I really shouldn't have done that string thing. I think I messed it up. All right. So yeah, now what if I want to check the first 5, for first 5 hits? So, right, so since I can access this basically like a list, I can say blast 5 till 5, but I cannot use description like that. What I'll have to do is like, you can make a for loop or list comprehension. So I'll make a list comprehension if you're all aware of it. What you can do is you basically compress the for loop, I guess, for hit in last queue result till like the first 5. So the first 5 lines of the hits, and whatever's inside that for loop goes in here. So hit dot description. So this line basically says for the first 5 hits, right? For each hit in the first 5 hits, hit dot description. It's kind of like a set builder notation. All right, so these are the top 5 hits, and they all seem to be coming from Yersinia pestis, right? All of them coming from Yersinia pestis. I don't know what that is exactly. Let's see. Right, so it's a gram-negative bacterium that's known to cause some plague. And that's what the DNA sequence here is coming from, right? All right, so we have 5 minutes left. First of all, any questions or any issues, anything? Anything you didn't get, any issues that might have come? All right. So yeah, you might have read that, you might have read here that we wanted to check if this subsequence is present. Oh no. If this subsequence is present in the file given to us, and if the GC content is above 55%. So using this record object, what I wanted to do is check substring and then check GC content. So try to do that. I would like take this function, whatever this function is, and then put it here because I don't want to, because I want to reuse my code basically. Yeah. Oh. And then I can run this. Yeah. So yeah, let me know, what do you get? Do you find the substring here? The substring. What's the GC content? Let's see who gets that first. And that can be basically kind of your check off kind of And with that, I'm going to stop recording so that people can